All right, guys. Hey, so let's talk about something. So this is a true 3D V-carve inlay, and it completely follows the surface, and it is completely inlaid into this piece of wood. So this top model is maple, and then we have some walnut base to it. I applied some texture to this stuff. We're going to go through all of this. We're going to go through the build process on all the machining. And then later on in the video, we'll go through all the Fusion 360 stuff that kind of went into to create this thing. But hopefully you guys have been paying attention, and something really big happened probably about 2 weeks ago, going into this week. So Corbin Workshop, I'll put all the links in the description to get over to his website, see his YouTube videos. He created a plugin that changed the entire game on how to do this stuff. And not only just flat surfaces, but 3D surfaces. And he produced some just phenomenal results with this thing. And the coolest thing is he completely automated it. And he's given it to, the community for free. So knowledge is power. You guys have to really go and check that thing out. At the end of the video, I go through a demo of the tool and just how easy it is. It is a game changer. And without that plugin, like, this would be extremely hard to do. And even though this is technically 3D above the surface, right? I went ahead and I modified what his plugin helped me produce, and then just kind of had some fun with it, some textures and some really cool stuff. So with that, let's jump right into the build video, and we'll get started. All right, so we're gonna jump right into this. And you can see in the background, I have a flag on the table. That is a wavy flag that I'm gonna V-carve inlay stars into the union. Uh, the union is walnut, the stars will be maple. So this test is gonna help me out a lot. And I ended up not doing a test, and I had a failed parameter that I kind of messed up, and I didn't have the plug depth strong enough, and it just ejected when I went back over on the profile. So this test is going to reinforce steps that I need to do to correct that flag. Um, but yeah, so let's talk about the workflow. And within the plugin that Corbin produced, he automated all the tool paths to a certain degree to get you started with the V-carve and the clearances required to get those plugs to mate correctly. Um, and we'll go through this at the end of the video when we start deep diving into Fusion and how to set those things up. But I added an additional clearance pass just to get the profile correct, and then it gave me enough clearance for my V-carve to go in and machine 0.2 all the way down to clear that material out. Pretty cool stuff. And the 3D toolpaths that Corbin generated, that gets generated when you run the plugin, they are super awesome to watch. And like, I was sitting there just kind of watching. I almost forgot to film a lot of this stuff because I was just watching the toolpath do its thing. And then it never fails. I popped that thing off, and it flew off the table, hit the ground, and it just so happened to hit exactly the edge that needed to be inlaid on the top portion of that star. uh, that stuff happens all the time, and it is what it is. Even though this is a test, like, I wasn't going to recut it. I was just going to see how it goes. I could not tell that edge was damaged at all when I inlaid those two pieces together. um, but yeah, the workflow, I definitely did the male body first, and then now it's time to do the female side. And again, doing the machine profile gets me to a certain depth so I can actually V-carve into it based on the flute length that I have on my V-bit. And I optimized a lot of these tool paths to ensure that I minimized all the chip out. And again, like, flat grain it's so hard to do this stuff on. Even on flat grain, like, it's hard on flat grain, It is hard on a 2D surface, and it is really hard on a 3D curvature. Even though you're kind of producing end grain as you 3D carve something, it tends to want to chip out, and it's hard to keep those edges nice and crisp, especially intricate things. And Corbin really covered that on his 3D test on the 8 ball that he made. The amount of detail was just insane. But again, you almost he had to convert back to end grain just because it held up so much better. But these tool paths were super fast. It was very, very quick. And, it was time to inspect just to make sure there was no obstruction for the two bodies to meet and join together. And it was time to glue up. And one of the biggest lessons that I learned from the wavy flag, which will get covered in another video, um, the glue up is extremely important. The amount of glue that you need to put in there is pretty substantial. It's not like a normal, joining two faces together. I made sure I put ample enough glue in there to make sure that it squeezed out and it joined those two bodies together. And that's something that I didn't do on the flag. And that was probably just a real big critical mistake that I made that flag fail. So I put it in the clamps for about 2 hours, and I was like, that's probably good enough. Let's just go ahead and cut this off and cut the profile. All right, so for the profile, I'm really excited about this. So I added extra material on the model to give it a really nice concave effect where it looks like the star is just sitting on it. And I used the thickness of that base of that plug as a foundation to do that carve. So right now I'm clearing out material because I want to make sure that my my V-bit won't run into a collision and it's cutting the entire top off. And as I'm cutting the top off, I am putting the actual texture on it also. So the walnut is getting a texture, and then the star is getting an additional texture on it. And this is a new feature on Fusion, and I'm still playing around with it. I'm going to do a video later on and just kind of go through those steps on how to apply it. You can basically apply it to anything, and it's actually really cool. But I was just a little bit disappointed on the star, not because I chipped the top off and it broke the inlay. That was a different issue, and it is what it is. Um, but I was really going for like an embroidered, stitched look for that star. And the depth that I put the texture on didn't really achieve it. I really enjoyed the walnut texture, but the star, I mean, it could have been a lot better. So I'm going to take that as a note, and future iterations, I think I can get a pretty good effect. For the chip out, I saw that coming, and I could see the chatter, and it is what it is. I let it basically just break off just to see how the plug would react to it. I basically just sanded that flat, and it's not really noticeable, but it is. But again, this is just a test, and it's a really good learning experience. I'll probably apply CA glue just to reinforce the plug, just to have additional contact where that chatter doesn't affect it where it's going to break right off. But again, this is just a test. I applied some oil, and then after the oil, like I really was interested on the plug depth and how it reacted on the actual pocket uh, bottom. Did I have a gap? Did I have a little bit of a gap? Did it bottom out? There's a whole laundry list of things that can happen. And so when I cut it apart, I took a little bit of time to really inspect it. And in the plugin that Corbin produced, you can control that setting very, very systematic, and you can have presets where different types of wood, different types of material, all of that stuff goes into the account there. So very, very happy with this result. All right, so we're going to switch gears here. We're going to jump back into Fusion 360. I'm going to demo the inlay VCarve tool that Corbin created, coded, implemented, tested. I mean, completely knocked this thing out of the park, and just the impacts it has on CNC woodworkers. This is a phenomenal tool, and it's going to change how uh, a lot of makers end up making their products. It's phenomenal, and I really want to demo it just really quickly. What used to take days for me to do the modeling, do the tool path, just for it to fail or not be successful. This thing is so consistent, and it produces the VCarve plug and the female body in a way that, I mean, you can get endless results that are consistent and achievable every single time. So I'm going to put the links to his video into the description of the video. Um, he has a 2D VCarve test and then also a 3D video that he just posted. The link to his website I'll put in there. This is the VCarve inlay plugin for Autodesk Fusion 360. There's two different files here. You can do the one that's free, or the one that donates, $5 for a license. That both files are 100% the same. The license doesn't give you anything, but what it does do is it contributes some money over to Corbin, because I can tell you he has hundreds of hours of developing this tool, coding, testing, implementing it, and then he's sustaining it. So he's already had a couple updates and released some fixes for some bugs that Fusion was kind of reacting differently. Um, and so it's just phenomenal. He has a really good installation instruction and documentation as far as terminology, what the actual solution is doing inside of Fusion, and it's taken all the guesswork out. So definitely download it. Definitely contribute to the cause, because man, Fusion should be paying him for this. It is a game changer. So, anyways, so once you download it, I'm not going to download it because I already have it. But once you download it and you get back into Fusion 360, you need to go to the utilities, and then you're going to need to go into add-ons and add the tool inside of Fusion. So to do that, in add-ins, you're going to select script or add-in from device. And then wherever you downloaded that file from, you find the folder, you select the folder, and hit OK. Once you do that, it's going to come and install this inlay plugin that he developed, and you have to activate it. So I have two versions here. One is the older version that's not active, and the other VCarve inlay that is. And as long as this is ticked, you can go back into your design solid. If you go to create, you can see the tool was added as an option to actually do this. So with this, let's go ahead and I'll show you just how fast this is. So I have the body that and the profile for the curvature. Let's go ahead and we'll bring the star in. So in order for this tool to work, you have to have whatever drawing file, STL, or whatever you're bringing in, it has to be above this working surface. So to do that, we just need to do an offset plane. I'm going to hide this body really quick. I'm going to select the bottom plane, and then I'm just going to bring it up above the body that I currently have. So as long as it's above this surface, this tool will take it and it will project it properly. All right, so let's bring our star in. Let's go to insert drawing. I'm going to select that paint plane that we just offset. And let's find, oh, where did I put that? There we go. All right. And I don't have to move it. This is all centered exactly what I wanted for my workflow. We'll hit OK on that. And there is my drawing that I want inlaid into this surface. So I'm going to hide the plane. I'm going to keep the star active. And what we're going to do is we're going to go into Inlay VCarve. Okay, so there's some options here. We're going to go through the tabs and some of the functionality here. So the first thing to do is definitely name it correctly. So this will be the star inlay. You could technically do multi inlays, inlays into inlays. There's a whole laundry list of things that you can get really creative in how it produces all this stuff. I usually keep it as a component. It's a little bit easier to work with. But you can uncheck this and it'll just make a body uh, that's not within a component. Uh, Components are always good to work with, and usually that's the standard to, have correct modeling. So for the profile is your drawing, and you can come in here and you can select it here, or you can go into the menu tree, select star, and then you have a decision to make. Is this a 2D surface or is it a 3D surface? And for this, it's definitely a 3D surface. And I'm going to go ahead and just select the body over my menu tree. The next critical point that we need to figure out is how large depth-wise that we want our plug. And I've experimented with 0.1 to 0.15 to I really like the 0.2 as far as meat for that inlay for the body. And it gives extra strength. You can do other options with it. I added material on top and I machined on top of that surface. If it was 0.1 or below 0.1, it can get pretty fragile. It can start chipping. There's a whole laundry list of things that can happen. This is a really strong, amount of meat for that, the actual inlay. So for the next one, we're going to leave this at 0.2. For the next one is, do you want to create a plug and do you want to flip it and make sure it's orientated correctly so you can insert it into the female body. So definitely leave these checked, and then the surface gap. So I paid attention to this with the profile that I was going to include, and then the excess amount of thickness for the plug. And that gave me thickness to machine over to bring in that 3D profile on top of the inlay. If you're not doing that, and if you're just doing, just a regular flat, very, following the curvature, uh, usually, this is a really good setting. I really do actually like it. It produces strength when you start taking the plug off, especially if you have a very steep contour that you're working with. And then the base thickness, again, I just left it at 0.25. The toolpaths tab, you can go through, and if you have toolpaths that are preloaded into your workspace, you can actually select those, and it will build offsets that allows you to use those type of bits. Right now, I don't have anything loaded, but I can tell you that I can tell the tool that, hey, I'm going to use a 30-degree V-bit, and I'm going to use at least a 1/4 of an inch clearing bit. For this, that 1/4 inch isn't really going to work, so I can put it to 1.25, but it'll build the offsets needed, so I don't have to adjust anything in the actual machining ops. Let's go ahead and hit OK, and it generated. Telling you guys, like, seconds, right? Just something this simple probably would take me about an hour just to go through, start messing around. I would have to do all the math, all the, the modeling, try to get it, to get it to this point. Takes a lot of time. He automated this to where it's almost instant. And bigger complex designs, it's doing the same thing. And, it's so impressive. It is a game changer for sure. So what it did was it created the inlay pocket, the actual inlay, and we can hide that, and then the inlay plug and the stock plug. So let's concentrate on the stock plug. And what he did, man, it's super genius. When I was doing trying to figure this out, the past couple years, and it was just so frustrating to me. And what he did was genius, and he ended up adding material that followed the profile. So the bottom of the plug is actually this profile, and he subtracted um, the tolerances needed when you sandwich everything in, and we'll go through the parameters and some of the terminology, but this is the bottom of that plug. And what ends up happening in the toolpath is it drags the V-bit along this bottom. It allows space for the gap that you specified when you generated it, that 0.05. Um, and then the thickness of the actual plug is built into this. So he created two bodies and then manipulated fusion to produce that chamfer needed for the inlay. It's genius. And the fact that he automated it, I mean, you can't ask for anything more. Um, okay, so let's dip into the parameters here really quick. And you can find this exact data in the user manual that you can download off of its website, or you can see it here. And you can see basically all the constraints that we built that model off of. The inlay depth is 0.2. That thickness of that inlay is going to be 0.2. The fit adjustment is at 0.03. I'm going to actually go ahead and I'm going to change this to 0.05, and I'm going to hit OK. That instantly changed that model. And let me do that one more time. Let's just go 0.1. When I hit enter, I want you guys to watch what happens to that body. Right? It's automatically adjusting it. And doing it this way, I don't have to regenerate or, edit undo or anything like that if I don't like something or something's kind of funky to me. But I can change things very simple within this. And this fit adjustment, some people call it a glue gap. I think his terminology is 100% spot on. When you talk about joining wood together, you don't talk about a glue gap. The same thing applies to inlays. And I think, back in the day, whoever created this terminology kind of just, misconstrued what was actually happening, and it just never got corrected. I am a firm believer within that. So, okay, so that's the fit adjustment. This is highly dependent on the degree chamfer, the type of material, and the face or end grain or whatever you're machining into. There's a lot of things that go into this, and you need to do some test cuts before you deep dive into a huge project. For this 30-degree V-bit, I ended up going 0.3, and it was almost perfect where it didn't leave a whole lot of gap, but it didn't bottom out. Very, very, very important. That is a strong inlay that's probably going to last the test of time for sure. The surface gap, the one that we went in for that parameter to have in there, that's constant. That's really good. I can change the thickness of the base plug if I really wanted to, or I could change the degree chamfer, say if I have a 15 degree. Things are going to change, but that's inside the toolpath, and they'll automatically update. I'm actually going to change this back to 30. And these settings for this 30-degree V-bit, I mean, that's exactly what I use for this test. I can hit OK. It's already updated, so everything within these components are true, and they're feasible. That would have been phenomenal if it would have just stopped there. But he went a step further, and he built predetermined toolpath setups. So you can actually go in here. This is from a previous setup because I was playing around with it. Let me delete these. Everything that you need is inside this area. So you can select your machine, whatever setup that you have normally, you can input into. You could add material with offsets. I like offsets, not for the sides, but for the top. So usually I'll cut 3" by 3" but I'll leave a little bit of skin, maybe 0.02 or 0.03 on top. So when I come in with my machining operation, I have some meat there just in case I don't cut it true or I don't have enough thickness. Um, I can set my stock type. I used to not Z or zero from the bottom of my spoil board. When I got the Avid, I mean, it is so streamlined to do this, and I think any kind of machine is more than capable of getting consistent results by doing this. So I used to do this, or in the middle. I'm 100% a firm believer now that this is my method now. Um, but yeah, so we can hit OK on that, and you can go into the first tool path, and everything is built in. So realistically, all you have to do is just select your V-bit that you're going to use. This thing runs at 100 inches per minute. I slowed this thing down to 40, not 400, but 40. And then what I ended up doing is I adjusted some of these tolerance levels. And I've had some really good luck with lowering the tolerance and then also applying smoothing a little bit more. It decreases the amount of points and it kind of streamlines the toolpath just a little bit better for my controller to process. This is 100% machine driven. And then what I also did was I applied feed optimization. So what I was telling it to do, and you kind of saw it in the video where it slowed down around these corners, I was concerned because I was on face grain. Um, very, very critical that these edges get kind of, not specifically for the female, but definitely for the plug. Those walls get really thin and the amount of chip out, I mean, it can happen. So I applied anything that was a 5-degree change would slow my feed rate down to 10 inches per minute. But then it would accelerate on the rest of the line depending on the distance that I set. So let me just hit OK on that. And you can see that it built this. Now, because I added all this stuff in and I'm V-carving really far down, I'm having collisions. So what I need to do is I need to clear this material out. And that's something that's not included in the plugin. This is only 0.5 worth of flute on this V-bit, and it can't get to this stuff, right? It's digging down into this material to get to the bottom. So we need to clear that out. So the easiest method is, and you got, well, not ramp, sorry. I like the parallel tool. And this is not a huge distance here. So I'll take a ball nose, either a taper ball nose or a straight ball nose. I used a 1/4 inch straight ball nose. We'll set this down to 150, not 1500. And then I'm going to select this boundary so it's going to stay within this area. There's a really critical thing that I was playing around with. This contact point boundary is really, really important. So it's using the complete radius of that ball nose where it's not stopping. So it's going to make sure it's going to machine the entire profile. Very, very, very important. Another thing that's important, and I kind of almost forgot it, is to include, because right now it's going to machine the surface and it's going to try to get into this area, and I don't want that. What I can do is I can go to model and I can literally select the plug inlay, the plug surface, and it will add that to the model. And so now it's only going to machine this surface. Let's go through. I'm going to put my tolerances down a little bit. Again, I'm going to apply smoothing, and then let's do 0.1 for the step over. We'll keep the tool down and we'll play it. Now, critical is we're going to pull this all the way up to the first. So this is going to be our first tooling operation. and you can see it machined all this stuff. And then we're going to reapply that V-carve. Now you can see that the V-carve went in, it had no collisions, and it cleared that out. I'm going to stop, where we're currently at right now. I'm not going to go tool by tool, but during the video to get this, the workflow is very important. And I wanted to make sure my zero was good. That's why I kind of built that little box around on my spoil board to make sure that when I put the material back in, it went 100% right back to where it was. And then the order of operations. So this plug was very, very important. I'm not going to actually, let's regenerate this. Generate. Yeah, that's fine. This plug was the first cut. I did that machining profile. I did the V-carve, and then I did a clearing V-carve, and then a clearance. And then I went to that main body and I started working on this. When it was time to do the plug, I added material on top of this to go in and machine and then account for that 1/4 inch plug additional, material that I added to this overall body. And then I used a V-carve just to cut it all off. So in the video, you probably saw where I had that chip out right at this tip of this point. I don't know in the video where you saw, like I was kind of messing with it. When I sped the video up, I don't know, I don't think it captured it, but I saw it start wiggling and there was some chatter and I was like, yeah, this thing's going to come off. And I just let it. I was going to glue it, stop the tool path, just put some glue, some CA glue really quick just to stabilize it. But I decided not to, and it chipped right out. That's a very real thing that has to be considered. It has a lot to do with this gap and the amount of points that it's holding on to and how that glue up actually, join those two pieces of wood together. Very, very important. But yeah, so I think I'll probably do another video on this texture feature. So this is actually, let's go back to the design here. This was a pre-built new feature that Fusion just added. And I was kind of going for this, this sewed, type of thread, embroidered look for the star. It didn't achieve it because I thought this was going to be more pronounced. I really liked this profile on the walnut. I think it was subtle enough where, you don't notice it, but then all of a sudden you get into it and you're like, holy crap, that's actually textured. How did you do that? The star didn't really get to that point. And if I was to make this more defined, which I can control into Fusion very, very easily. And it's a really powerful tool. I'll do a standalone video on that. But regardless, man, I really wanted to concentrate on this new plugin that Corbin produced. This guy, he has completely changed the game for CNC woodworkers that use Fusion. I don't know any other software, Vectric, I don't know if they can handle this. And the amount of the amount of detail that you can get to, that you can visualize, understand the stock, manipulate it in different ways, add to, subtract in a very streamlined manner. It has completely changed that game. So I don't have any history with Vectric, so I couldn't say yes or no, or maybe on whether, if they have a better method or not. All I know is this free software of Fusion 360 is producing, very intricate, machinable inlays that are repeatable. And you can't ask for anything more than that. Okay, so let's, I think that's going to be it. I really do appreciate everything, guys. If you made it this far in this demo, I apologize I didn't go more in depth. I am doing a big wavy flag right now, and I had actually a failed because I messed some settings up for the V-carve inlay. So I'm reworking that. and I'll probably go a little bit more in depth on some of the things that I learned. And yeah, no, I'm super excited, and I can't thank Corbin enough to, dedicate his time and produce something for us to play with. So, all right, guys, have a great night, and I'll see you on the next video. Appreciate it.